Okay, thank you for coming back after the long holiday. I hope all of you had a good holiday. And so, as I said earlier, we will have a guest speaker speaking to you about uh, fintech. He's from Scott Chen, is from Bank of China. So, hopefully, because uh, you should be graduating this year or a year after. So it's good for you to know what the job market is like to better prepare yourself for the future. Similarly, for this course, software engineering, uh, in fact, uh, there, in the most recent graduate ceremony, mid-December, I already left for Toronto for my annual leave. But so Andrew, he talked to a number of graduates about asked them like to take some video of them to show to secondary school students to promote our program. Some of the students said they thank me for this course for teaching them software engineering because uh, these are the things that we teach in this course. Students, most of them do not appreciate while they are students with us, but the longer they graduate, they tend to appreciate more because the things that we teach here sometimes maybe is boring for them. Okay, when I recall myself, when I was a student, I did not have a software engineering course. At that time, when I was an undergraduate student like you, the closest thing we had was a system analysis course, but I didn't like the course. But then, of course, it was stupid. Later on, uh, the things learned in that course was really useful. Okay, so let's move on to a new topic today. It's called code refactoring. And you may recall this diagram. What are we explaining in this diagram? This diagram shows test-driven development, TDD. Okay, so TDD, we've seen it just before holiday. TDD is one of the agile methods, one of the very well-known agile methods. And normally, I think many of us, when we think about testing, we always think about we need to build the product first and then do testing. But look at this case right here, this steps, the procedure that it is showing. It says, well, I know you miss each other after a long holiday, but let's do that. I'll give you time to talk during break time. Okay, so please keep your voice down. Okay. So this TDD put the writing program part in sort of in the middle. Okay, and the test was actually written first. So you write test first, and then you run it, and you make sure the test shows that your program is not fulfilling that requirements shown captured in the test, because if it's already met by the existing software, then something's wrong because we are saying we are developing new features. Okay, so this TDD, we are trying to build new features or build programs. So initially, the program must not meet the requirements. So we write a test and make sure that the test fails. Now we write the production code, write the actual software. Okay, So these two square boxes are both software writing, but this one is writing the automated test, but this one is writing the test that the user will need. Okay, so and then we run tests until everything succeeds. And there is a last step here that says clean up code. Okay, so that square part is what we say code refactoring. Okay. So this chapter, this week, we would try to explain to you what is code refactoring. In other words, what's the last step here, and why do we want to do that? Okay, we will introduce a very simple term, code smells. Code smells basically means something's bad. Like when you smell food, rotten egg, 壞咗嘅蛋, okay? You smell something bad. So this refers to bad smell, okay? So that means how we would explain to you how to detect bad smell in code. That means something needs to be fixed, okay? Something is bad about the code, okay? Because bad smell code makes programs difficult to read and modify. And code refactoring actually consists of many dozens of rules. Like I can't remember the exact number, but quite at least 50, 60 rules. I roughly recall they may actually be 100 rules. What are the code refactoring rules? They are rules that explain how to change a program. So after changing a program, the program is changed a little, and that is supposed to improve the program structure. So that's what the code refactoring rules are, and we will not have time to learn all of them, so it will be very boring for us to go through it in class. So I would just explain 5 to 10 rules here, just to let you feel what it's like, and I'll show you where to learn additional rules. And in software engineering, we try to make use of tools to help our work, and code refactoring is no exception. In fact, the popular IDE such as NetBeans and Eclipse, they has built-in code refactoring features. So next time you use IDE, you use NetBeans, you can look it up, and they can help you do code refactoring. Okay, so this is the main topic of this class, and let me keep the time because we have. So the purpose of code refactoring is to improve the program structure and make it easier to read and easier to maintain. Okay, when you look at this diagram here, this part, there's a arrow here that going back. Like if we run some tests and if it fails, we go back to update the program code a little bit and then run again and maybe update. So this loop here means we try to make the code work correctly. In fact, agile people have this mentality that we first try to make the program work correctly. Okay, we want to make the program work correctly before we want to make it look really nice. So that's why they leave this part of making the code look nice, elegant, like easy to read, easy to understand part to the last part. You can also think of it as an approach called divide and conquer. So first, we focus on making the program work. Later, we focus on making program look nice. So you sort of focus on one thing at a time. So that is the part of code refactoring, is to make it look nice, have a good readable program structure. And there's one criteria is that code refactoring should be should keep the program behavior unchanged. Okay, make it unchanged. For example, here, if we clean up the code, and if we will change the program behavior, then we are asking for trouble, because if we change program behavior here, it means, well, maybe the test will fail again. Okay, so after it's successful, we only apply the code refactoring to ensure that it won't fail. Okay, so this, I guess there may be a small simplification here, because after cleaning up the code, probably we also still want to run the tests again. So after cleaning the code, we probably want to go here to make sure that the tests still succeed. Because sometimes, maybe when we do code refactoring, accidentally we change the program behavior, then a working program may become not working. So this we want to test. And also this asks us to think about the importance of automated testing. Okay, so if we can write programs to test programs, then that's great, because after we did code, all the tests right here, all the tests that we have, can be reused over and over again. Okay, but of course, if you are writing front end can still be automated front end testing, but is not as easy to test as back end code. Okay. So do you know what's the difference between front end and back end? If I ask you this question, okay, front end means it is some program that the part that the user can see. Okay, the user interface is the front end, and then there's the back end. Back end is usually, it may appear in the form of like API. So another program call it. Okay, so back end. So there's the difference of when you're a programmer. Some programmers may write the front end to show to the user, and then the other programmers may write the back end to do the actual work. Okay, so usually back end code is more easily you can write automated testing for it. Okay. So the point 3 says each refactoring rule only change a program a little bit, but in the entire cleanup exercise, you probably would repeat multiple rules multiple times. So altogether, it will still change the code a little, a bit. Okay, although each rule only change a little. And why do we want to code refactoring? Is because we detect code smells, bad code smells, which is explained here. Well, code smell, we said, is something bad about the program. But what is good, what is bad? You can think of the task of programmers a little bit like a craftsman. Okay, a craftsman in Chinese 係一個工匠。Okay， 一個工匠 when and the work they do involve a little bit of creativity. So I guess the fun part of being a programmer is that the work you do, you can think of it as some creative activities, okay? And you can write a program that is uh, very beautiful to look at, and people would think it's beautiful, okay? So in some way, you can think of your work not exactly like painters, okay? We know two of the most famous painters are Picasso, okay, and Vincent van Gogh, okay. So their work, some people may like the work of Picasso, other people may like the work of Vincent van Gogh. So whose work is better? Well, when it comes to artwork, it's hard to say which one is better, which one is not as good. To some extent, programmers' work product is a little bit like that too. Sometimes it's not so easy to say absolutely which is better and which is not so good. So same for Coke smell, something that people may think is bad, but then other people may think it's okay. So let's look at different level of code smells. We will look at application level, class level, and method level. Okay, so let's look at the application level code smell. That means throughout the entire application, one being duplicated code. Okay, that means identical code okay. That means a piece of code that is identical, you put it in multiple places of your system, or they are very similar. You just change a small parameter. Okay. So what we would so if okay. Um, So if we have duplicated code in multiple parts, imagine when you are a maintenance programmer, you know the work of maintenance programmer. Like today in school, all of you always write new programs. But when you go out to work, it's changed, okay? Lots of time you will also be uh, modifying program. We call it this activity software maintenance. Okay, uh, so don't think that writing new program is your only activity as programmers. Lots of time you may be reading existing program with many hundreds of lines or even thousands of lines. You would just need to look for one place to change one little thing or just a few lines. So that means as a programmer, you have to do software maintenance work. And imagine you are maintaining some existing work if they have duplicated code in many places. And you know something has updated. Perhaps it's a security requirements, you want to change it. Well, you just change one or two places that you discover. Maybe you overlook the duplicated code elsewhere. So what will happen? Then your system will behave inconsistently depending on which one of the duplicate code is executed. So that is, if you have duplicated code in a system, it's like you're leaving a trap for 一個陷阱, okay, for other programmers to step on it. So that is bad. So this part is definitely bad. This part, I guess, is there's no argument. So we all think, if possible, usually you should avoid the duplicated code, perhaps make it into a method call so that anytime you need it, you just call the method. So that would be a better thing to do. And the other one is contrived complexity. That means you are using very complex code. In fact, more complex code than necessary. Okay, so that is why it's bad. Well, sometimes we may want to design the code so that it can do something in the future, many different things in the future. Okay, but maybe we never need that feature. So if you write code very complex, again, sometimes it makes things slower. Even if it's not slower, then the maintenance programmer looking at it, who did not write the code, will have a difficult time of understanding it. So that's why these duplicated code and complexity are considered bad code smell. Okay, another things is class level. Now we're talking about individual objects, individual class. Okay, bad code smell in a class include you're making the class very large. That means it tries to do too many things. You have too many data fields in it, too many data members, and it tries to do too much. And sometimes programmers, because if you need to break up different things into different objects, then programmers need to think, how do I do the division? Okay, so some programmers are too lazy to think, so they just add everything together and make it one huge object. But it has the disadvantage or problem that the focus or the purpose of that object becomes unclear because it tries to do too many things. That's one problem. Another problem is that the code, the resulting code will also be very hard to understand. Okay, so it's a good idea to keep the objects, keep the class not too large. Okay. And feature envy is another bad code smell. It means an object uses the methods of another object too much. Well, if this happens, how do you think you can improve, simplify your code? Okay. Well, maybe the methods really that's being called from another object maybe belongs to this first object. Okay. So this, we call it feature envy because it increased the needs to communicate with different objects, and it's sort of make things a little bit complex. Okay, so consider to move the method to this class. And another code smell is inappropriate intimacy. Intimacy means very close, so close that, let's say, if I have a friend, an intimate friend, that means I know lots of things of her or his. But sometimes we may know too much. Okay, we may know too much. And in the case of OO design, what is knowing too much? Okay, let me remind you of the old day of OO programming. Okay, in the old day of OO programming, programmers, especially programmer of C++, they may access variables in another object, okay, directly, okay, and that can cause problem because if that other object change its internal implementation, but now we are assessing its variables directly. That means when that object changes internals, then the code may break. So that's why modern OO practice require us not to access an object's property by using its variable, but by using something we call getter or setter. Okay, we use getter and setter to get some properties, internal properties of it. Okay, so so two objects only interact with each other through the interface, not through direct access to the variable. So this using the getter, setter, or using methods can get rid of this intimacy problem, being too close, knowing too much. Okay. And let's look at another code smell. If you have think of geometric shape, okay? Suppose we have some geometric shapes. We have methods to calculate areas of these geometric shapes, okay? And consider two classes, two objects. One is square, one is rectangle, okay? And which one do you think should be the parent class if we are defining a class hierarchy with these two objects? Should square be the parent of rectangle, or rectangle be the parent of square? 明唔明個問題啊？即係譬如如果我哋而家設計一個 OO 嘅一個 OO 嘅 class hierarchy， 咁主要嘅目的就係譬如我哋計下啲 area， 計下呢啲咁樣嘅嘢咁樣。咁你覺得我哋應該係個 square 係個 parent，rectangle 係個即係長方形係個 child 啊，抑或係 rectangle 係個 parent，square 係個 child？有幾多個嗱？試下你有幾多個唔肯定嘅？有冇人唔肯定？冇人唔肯定。咦？嗱，咁我跟住問啦，如果即係就你是但要舉一樣手咯喎。咁啊，邊個覺得應該係個 square 係個 parent 㗎？有幾多個覺得個 square 係個 parent 㗎？有冇人覺得？咁有冇人覺得個 rectangle 應該係個 parent 㗎？有一兩隻手 ，OK 嗱。咁其他可能太唔夠時間啦。I guess it's a deep problem because maybe you have never deal with this. Okay. When yeah, actually there's a hint. There's a hint when we say OO hierarchy. Okay. Usually, is it the child or the parent? We say is a specialization. 我哋通常係指個 child 係一個 specialization 啦，因為個 parent 係個 specialization 嘅。通常係個 child 先至係個 specialization。咁通常咧就係嗰個 child 咧就係做多啲嘢嘅可以 ，OK， 即係話個 child 咧。係個 capability 咧係多過個 parents 嘅 ，OK， 即係個 parent 咧係好，我哋通常 OO 嘅 design 咧就係 start from a very general root class，OK，that's not so much, very little thing，OK，not that much，OK，and then at each level down you can do more and more，OK，and so based on that, which one do you think can do more? Actually, in a way it is, or which one is the specialization? Actually, it's the rectangle. Okay, rectangle is the specialization because 雖然你都可以調翻轉頭嚟拗嘅，即係但係嗱，因為個 rectangle 嘅 height 同埋 width 咧係可以係 different 嘅 ，OK， 咁所以你可以將呢個咧係睇成係一個嘅 specialization， 一個 added 嘅 ability，OK，so the rectangle has an added ability，so this is why in the general OO design principle we want the child to have more capability. So and the parent is like can be not so dumb. I guess many of you would think you are smarter than your parents, right? So for OO, the child class should be smarter, should be able to do more things. Okay, so maybe so I guess based on this, we would say it's better to derive rectangle class from square class. So rectangle is the child, the specialization, and square is the general, is the parents. Okay, so this, so sometimes people make mistake in this area. People think they're related, but then they get the order wrong and they put the wrong class as parent. Okay, so that imagine 即係嗱，如果我哋有時即係嗱，其實亦都點解我哋係有咁樣係由 parent class 係好 general 啊咁樣，然之後一路係要越嚟越多 specialization， 而唔係調翻轉嘅。其實 reuse 個 idea 就係咁啫嘛，即係先頭咧就係 you may not provide lots of features, you may not be very complex, you just do some basic stuff. Each level down, you do a little bit more. Okay, this is, I guess, the proper direction. If you are being inconsistent, sometimes the child is smarter, sometimes the parent is smarter. I guess that will make things so sort of confusing. Okay, so we want the design of class hierarchy to go lower level, more specialization. Okay. And another bad code smell is called lazy class. Lazy class means a class does very little. Okay, the problem is with lazy classes means you will end up having too many objects. Okay, because each object do too little. So you can almost see large class and lazy class as opposite. 即係話doing too much is bad, and doing not enough is also bad. Doing not enough means you have excessive number of objects, different classes. Large class means you have small number of classes, but each class is too complex. So the optimal thing is to I guess Chinese people know about this 中庸之道 ，OK， 就係啱啱好，唔太多，唔太少 ，then that would be perfect. Code smell. Another code smell is excessive use of literals. The word literals means 呢啲，譬如個 number 5咁 ，this is a literal, OK。或者一個 string 嗰啲又可以係一個 literal。And if you have a number 5 here, then when you write the program, okay, when you write a program, assuming your program has something to do with number of work days, okay, and the number of work days happens to be 5. And if you hard code the number 5 in your program, someday, if let's say a unlikely case that number of work days is reduced from 5 to 4, okay, then you have to look for all the 5 in the entire system. 但係咧， all the 5 in the entire system, is going to be like you find so many other 5s. Okay, so it's best for you to give a named constants. For example, using capital letter work underscore day to represent this value 5 to replace the literal. This will make your program easier to manage. 其實可能你you may not know in Hong Kong 30 years ago, I think most companies require staff to work 6 days a week. Okay, and then I think probably about 30 years ago, it's starting to change that many people only need to work 5.5 days. And today, probably more and more company only require you to work 5 days a week. So these things it's better to keep it as a literal. Keep it as a named constant. Another thing is, for example, if you are writing a point of sales system, okay, POS system, 而家膠袋要俾錢㗎嘛，係咪？要俾5毫子㗎嘛 ，okay? Well, what if they change it to $1 in the future? So if you hard code the plastic bag tax to 50 cents, then when it's changed, you have a more difficult time to update your program. So it's better to define a named constant, and it's very easy to read too. Another bad code smell is called cyclomatic complexity. That is about having too many if then else, too many loops, too many branches. Okay, downcasting, we'll see it on the next slide, and often variable or constant. It means a class is holding a variable that really does not belong to it. It should better belong to the other class. So actually, this often variable and the feature envy may be related. Okay, they may be due to the same reason, or it's two sides of the same coin. Because sometimes, why do you need to use a method from another object a lot? Well, because it has the variable that you need. Okay, so these two may be related, and if you solve one, possibly you may solve two. In OO, sometimes we would cast an object from a child class to the parent class. For example, fruit is the parent class and apple is the child class. So if you do something like this, parent, you cast a parent to apple, and that even the programming language allows you to do that, but actually is one thing is very risky. Okay, so this is called downcasting. So you cast an object from the parent to a child, the type of a child class. So that is dangerous and a bad idea. The other direction, upcast, is more okay. So if you have an apple, you cast it to fruit, then that is okay. In fact, that is a common OO technique to cast a child object to the parent object. Okay, but so upcast is okay, but downcast is bad. Okay, we have talked about bad code smell at the class level. Let's look at method level. The first one is having too many parameters in a function. So when you write a function or method, try to limit the number of parameters that you have. Okay, in the old days as a C programmer, I see many C functions, even if they are from a library, a well-known library. Okay, sometimes they have this sort of bad design. Okay, with 5 parameters or even more. Okay, that is too much. But why we don't like about it? Okay, well, if you have many parameters, that means it's sort of easy to make mistake. You do it in the wrong order. Okay, that's one thing. Okay, it's very easy for the user of that function to mix up the order. That's a problem. Another problem is if you have many parameters, that means there's a good chance that you may be trying to do a lot of things with one function. Okay. Earlier in the bad code smell for class level, we say we don't want overly large class. And in here, we said a method, we probably don't want to have overly large method or long method or too many parameters. They are related. That means your method, the reason that your method has many parameters is perhaps, well, you try to do many different things. So the purpose of that method is not clear. Okay, if the purpose is not clear, then someone tries to use your method will have trouble. Okay, they need to spend longer time to learn to use your method. Why your method? In fact, this this sort of problem, I guess, the focus thing is a very important technique. OK， 嗱我試下用中文講啦，就係、譬如如果你一個 function 有太多 parameter， 有可能就係你想俾佢做太多嘢咧。咁但係做太多嘢有咩唔好咧？就係、人哋睇嘅時候難明啦，甚至乎我哋有時寫啲 email 啊，亦都係喎，即係我順便可以講一講，即係如果你寫 email 俾個老師嘅時候咧 ，OK， 你想個老師幫你做一啲嘢咁樣，如果你喺同一個 email 嗰度咧request 佢太多嘢嘅時候咧，你估你個老師會有咩機會啊？嗱，即係有咩嘢可能會發生啊？可能咧你叫佢做5樣嘢咧，佢可能會淨係做咗3樣4樣，佢會做漏1兩樣咯。OK， 咁其實即係呢個係人同人之間嘅 communication， 你一次過即係俾太多嘢嘅時候咧，對方 handle 唔到。其實當我哋睇一個 program 嘅時候咧we can almost imagine we are doing some sort of communication. One programmer write a method for another programmer to understand. If we try to do too many things together, okay, and people cannot understand. So that is why we say too many parameters, trying to do too much with a very long method, that is probably a bad idea, okay, because of the lack of focus. And okay, if an identifier is too long, then you cannot fit a statement in a single line, one screen. People have to scroll like 100 columns, like 100 characters, and that would be bad. Okay, and of course, short names, short identifier, just X, Y, Z also may not be good too, because we just know it's a number and we don't know what it is. So try to use some appropriate length identifier. Okay, and this last part mentions some techniques in C programming. Okay, some people would use a prefix because C program has a unique thing that does not exist in Java is that they have some header file. Header file, they may include define some variables, some names in it. So they may use, so the same header file may be used by lots of .c files. So sometimes you can use a nice prefix uh, to identify the meaning, okay? But more and more with Java, we don't do that global include, okay? That's this sort of header file. So this is the need is gone, and when you return value from a function or method, same reason, you don't want to return many different pieces of data at the same time, because uh, then it's harder to understand, and people may get it wrong, and you may be doing additional work that is not needed. Okay, this but why would programmers make this sort of mistakes? Because they sometimes they try to do too much. Maybe after the break, we'll go through this last one, complex conditionals. But let's take a break now. Our speakers may be here or maybe outside, so we'll take a short break. Our guests for our guest speaker.